Hi, my name's Brom, and these are my teammates, Austin,
Hey.
George, John. We all work here at Lawrence Tech as engineering students.
We formed our team in our engineering design studio class, where our professors introduced us to Services to Enhance Potential, or STEP, located in Dearborn, Michigan. Here, people with disabilities learn the skills they need to succeed in their future career paths. At STEP, employees gain experiences and abilities in a factory-type setting and get paid for the work they do while they're there.
At STEP, the biggest opportunities we saw were with the strut design. As you can see here, the strut holes do not align. This makes it difficult to insert the bolt. In addition, it also takes a lot of coordination to assemble the struts in the air, and the employees often overturn the nut beyond the 3 to 4 turns that they need.
On top of these issues, many of the employees at STEP have dexterity impairments, meaning assembling struts is even more difficult. Some employees only have the use of one hand. With these impairments, strut assembly is either painfully slow or completely impossible.
With these pains in mind, we set off to create a device that would help our SMEs and other STEP employees assemble struts more efficiently. Our first prototype was a mold. After testing, we soon realized that the mold was too restrictive and bulkier than necessary. This led us to our second prototype, the platform. This was better, but limited strut assembly to a single strut and strut size. Since STEP manufacture dozens of different struts using 3 distinct bolt and nut sizes, we decided the platform needed to be more universal.
Our desire for more universality led us to the cube. The cube offers 3 sides for our assembly of 3 different classes of struts, small, medium, and large. Our goal was to manufacture many of them, giving STEP the ability to line up the cubes side by side and mass assembly the struts. We created a CAD model of our idea and 3D printed it for testing. However, after taking it to STEP, the employees told us that the walls were too restrictive for turning the nut into the strut.
We updated our design to fit the employees' needs, completely eliminating the cube's walls by rotating the large bolt holes to the center of the cube. With this huge update, the Cube XL was born.
The Cube XL has complete free range of motion for the strut assembly, allowing STEP employees to tighten the nuts onto the bolt with ease. The lowest level is for small strut assembly, the highest level is for large strut assembly, and the middle level on the back is for medium strut assembly.
Here's how it works. An employee begins by attaching the desired amount of Cube XLs in a line using the cube's side magnets. We like using 5 cubes since that equates to 10 struts assembled at once. Then the employee goes down the line, placing bolts into the bolt holes, and follows that with 2 struts per bolt. Finally, they secure the struts with a nut each and place them in a box for shipping.
The Cube XL setup is stationary and sturdy.
Side magnets hold them together, and a magnet on the bottom secures them to the metal table.
Besides offering free range of motion and holding the struts stationary, the Cube XL setup also offers the following benefits. It's easy to use, it can be done single-handedly, it has mass assembly capabilities, and it's more fun and entertaining for employees than the old way.
When STEP employees used their hands to assemble a box of small struts, it took them an average of 27 minutes and 1 second. When they use the Cube XL assembly, it takes only 13 minutes and 46 seconds. This is nearly half of the original time. We also increased how long STEP employees can stay focused.
But wait, there's more!
We also designed and developed the nut counter and the cup attachment devices, which aid in the counting and packaging of struts. In each box, there must be 50 small struts, 25 medium, or 25 large struts. Before, employees would lay out their assembled struts on mats and have to individually count them before placing them into boxes to ensure they counted correctly. Our devices make that process much simpler.
Here's how it works. An employee counts the necessary amount of nuts for the job, using the nut counter that corresponds to that size, small, medium, or large. Each peg fits 5 nuts, and once an employee fills up each peg, they know they have made the perfect amount of nuts for the job.
Then, STEP employees dump the nuts into the cup attachment, which has magnets on its side, that matches up perfectly with the Cube XL assembly. The employees place the cup of counted nuts at one end of the assembly, and another cup full of bolts at the other end.
These cup attachments keep the employees' workspaces neat and organized, further increasing their productivity.
As they assemble struts, the employees place the completed ones into a awaiting box, and once they are out of counted nuts, they know they have made the perfect amount of struts.
With the Cube XL, nut counter, and cup attachment, we have found solutions to nearly all of the pains STEP employees face when assembling struts.
Besides accomplishing our course requirements, we also decreased strut assembly time by nearly half and increased the amount of time that an employee can stay focused on the job.
This productivity increases even further when you consider our nut counter and cup attachment devices, which lower packaging and counting speeds. Besides just increasing the employee's productivity, we are able to leave STEP knowing that we made a lasting impact on their strut assembly processes, subject matter experts, and other employees as well. We have made their daily jobs easier and more enjoyable. We can only hope that we have given them the foundations they need to succeed at STEP and in their future careers, wherever else that may be.